Hello friends, I welcome you all in this session. As you are aware, in previous session we discussed about lags in precedence relationship, and we have seen 4 types of lags. You have got start to start, start to finish, finish to start and finish to finish. Apart from this, we have also seen how to draw a Gantt chart in Microsoft project. Now let us look at another concept in network. It is called laddering. Now laddering is nothing but a process of subdividing an activity so that we can complete our project in somewhat lesser time, right. So it is basically a technique that allows us to redraw the activity network to more closely sequence project subtasks to make the overall network sequence more efficient, right. So at the end of the day, our objective here is to efficiently complete our project in time, right, in fact before time, right. So it also helps in keeping project resources fully employed. So we will take up an example. So there is a project which has got 3 activities. You have got design, you have got coding, and the third one is debugging. Now this is how this network looks like. So activity A is design, activity B is coding, and C is debugging, right. So activity A is taking 3 minutes or 3 days, B is taking 6 days, C is taking 9 days. So what is the total duration of this project, and what kind of lag relationships are there? It's finished to start, right, and there is lag is 0, right. Similarly it's also finished to start, right, lag is 0, right. So tell me how much time this particular network will take for completion. It's very simple, right. It's 3 plus 6 is 9 and 9. So total 18 days or 18 months or 18 minutes or whatever it is, right. Now if we redraw this network like this, so we will breaking activity A into 3 sub activities, A1, A2, A3. So what we are doing, we are starting activity A and its subtask is A1, right. So similarly you can divide activity B also as B1, B2, B3. So divide activity B whose duration is 6 days into 3 subtasks, each has got 2 days, right. So this is 2, 2 and 2, right. Similarly activity C, we know that we cannot complete activity C unless and until we complete activity B fully, right. So activity C can be divided into again 3 subtasks, each has got 3 days duration, right. So C1 3, C2 3 and C3 3. So this is known as laddered ABC, right. And what would be the duration of this network now, laddered network? How much time will be reduced? Just think for a while and give me answer. Okay. So I hope you would have found answer, and the answer is 12 days, right. Initially it is taking 18 days, but when you go for laddering it is taking only 12 days. So just see here, laddered ABC is equal to C1, and C1 can only be started on 4th day, In other words, after 3 days you can start C1, and since C3 is taking total 9 days, and you cannot start C1 before 3rd day, right? On 4th day only you can start C1. So C itself is taking 9 days, and you can start it as early as on 4th day, right, or after 3 days. So total duration would be 3 plus 9 is 12, right. So this is known as laddering, a very effective method of reducing duration of the project. In fact, the concept here is there are some activities, some successor activities you cannot start unless and until you completely finish preceding activity, but you may have a set of activities wherein you can start succeeding activity after few minutes of start of preceding activity. So that is the situation here in this particular example. In only those situations you can do laddering, otherwise you can't do laddering, right. Let us look at another concept, it is called Hemic activities. In fact, Hemic activities are those activities which we use to summarize for some subset of the activities. In a project you will have thousands of activities, but you will have some activities which are very small, which do not generally consume much time, much cost and so on, right. So you just group those small activities together and combine them, and you can keep them hanging below in the network like this, right. So activity A, B and C, it is taking 5 days, this one is taking 10 days, this one is taking 3 days. So total duration is 18. So you can just combine all of them and hang over here, right, in a project. So let me draw a network in which I will fix this particular Hemic activity, right. So let us say this is activity 10, 20, 30, 40. So let us say this is taking let us say 29 days, 35 days, 40 days, and these are some other activities, right. Let me put it in this way. So this is A, B and C. So this is Hemic activity, this is H. So what I have done here, I have just combined all these 3 activities and I have just taken one activity, and I will call this as Hemic activity, right. So this is useful with a complex project or one that has a shared budget, right. So Hemic activities. Let us revisit the concept of critical path. We have already defined it. The largest duration path is the critical path, and project cannot be completed in less than that time, right. So let us take this example. Now this is the very first example of PERT network, right. So far we did find critical paths and semi critical paths for CPM network, right, not for PERT network. So, this is a PERT network and we will find out critical path for this particular network. So, let me draw this network and we will find out critical path. So, you have got a PERT network. So, this is okay. Since I need to prepare a table over here, so I will draw this network like this. This is 10, this is 20, 30 and 40, right, and the time estimates are 8, 10 and 14. Then we have got 6, 8 and 10. So, you have got optimistic time, pessimistic time and most likely time, 7, 13 and 19, right. Anyway, whatever is the value, you just you need to calculate TE for this, right. Then you have got 6 from 20 to 50, you have got 70 and you have got 60, right. Durations are 6, 8, 11, then 30 to 70 it is 12, 16, 18, 6, 7, 10, and there is one more activity from 50 to 70 and its duration is 5, 7 and 10, then 50 to 80, 80 to 100, which is the last node, then you have got 60 to 90 and 70 to 100. The time durations are 3, 6, 10, 3, 6, 10, 8, 80 to 100 it's 10, 13, 16, 13 and 16, 70 to 100 it's 7, 12, 18, 3, 5, 8 and 12, 15 and 21, right. So, let us try to find out critical path for this PERT network, right. So, how many paths are there? First of all, how many paths are possible? Forget about which path would be critical path. In this network there are 4 paths available. This is the first path, right, 10, 20, 50, 80 and 100, right. So, let us call this as path A, right. So, path A, right. Then you have got path B, 10, 20, 50, 70 and 100. Call that as path B, right. Path B. Then you have got 10, 30, 70 and 100, path C, direct path, right, path C. And finally you have got path D, right, which is 10, 40, 60, 90 and 100, right. Let us find out TE values. So, if you look at path A, you have got activity 10 to 20, 10 to 30 and 10 to 40, right. Only these 3 activities are there, right. In fact, it's from 10, 20, 50, 80 and so it's 10 to 20, 20 to 50, 50 to 80 and 80 to 100, right. So, this path A, right. And since you know what are these values at for this activity 10 to 20, rather than writing all these values again, I am directly writing TE, expected value, right. Now how to find out expected value? Expected value is what? TP plus 4 times TM plus TO divided by 6, right. So pessimistic time 4 times most likely time plus optimistic time divided by 6. So for this particular value, this is 10.33, 8.17, 6.17 and 13. Just check whether this is correct or not. Check it for 80 to 100, right. So 10 plus 16, 26 plus 13 into 4, 26 plus 52 is 8, 78 is divided by 6. So 78 divided by 6 is 13, right. So this is correct, okay. So T for first path. Similarly, what are the activities on path B? You got 10 to 20, then 20 to 50, 50 to 70 and 70 to 100, right. So this is path B, this is path C, right. So for path B, just calculate all these T values using this formula, right. So let me write down values for path B. It is 10.33, 10.33, then you have got 8.17, then you have got 7.17 and then 12.17, right. So it's 10.33, 8.17, 7.17 and 12.17, right. If you wish, you can check one of them. Let's check for 70 to 80, right. 70 to 80. So 7 plus 18 is 25 plus 48, 25 plus 48 is 73 divided by 6, right. So this would be 12.17, yeah, right. So now you can write T values for path C and path D. Which is path C? It's 10, 30, 70 and 100, right. 10 to 30, 30 to 70, 70 to 100, right. Only three activities, right. So this is path C, right, and 10 to 30, it is TE is 8, it is 8, it is 15.6, it is 12.17, right. So you can check any one of them, right. Similarly path D, right, this do the similar calculation for path D also, right. Path D is 10 to 40, 40 to 60, 60 to 90 and 90 to 100, right. 4 activities along this path, and the time durations are, it's 9.34, then you got 7.33, 5.17 and 15.5, right. Now we have calculated all TEs, right, for all these activities. Now you need to find out critical path, which path is the critical path. So for that, what you should do, you just sum up all these values, sum up all TEs along each path, right, TEs. So when you take sum of all these paths, sum for path A is 37.67, right. Similarly for path B it is 37.84, for path C it is 35.84, and for path D it is 37.34. So which path is critical path? Critical path is the path which is longest path, right. So longest path is for this. So what is critical path in this case? The critical path is this one, 10, 20, 10, 20, let me write like this, 10, 20, 20 to 50, 50 to 70, 50 to 70, then 70 to 70 to 80, this 70 to 100, right, 50 to 70 and 70 to 100, right. Path B, yeah, it's 70 to 100, right. So this is the one, right. So what we have done in this case, rather than calculating T's and TLs, we have just calculated T's for all these activities and summed up all those T's, right, and we said that this path is critical path, right. So this is one of the ways of finding critical path in a PERT network, right. So this is, you can see answer over here, yeah. So this is the final answer, right. Now if I ask you to find out what is the variance along critical path, what will you do? So variance is very simple. First of all, for this particular network, try to find out what is critical path, and then after finding critical path you need to find out variance along critical path. So let us try to solve this question. So this is a question having 8 nodes, and we have to find out what? We have to find out variance along critical path. So first of all you need to find out critical path, right. So let me draw this network first. This is a network which has got 8 nodes. Okay. 10, 20, 50, 30, 40, 80, then 70, 60, so 60 to 70, 70 to 80, and the time durations are 5, 12, 17, 8, 10, 13, 8, 10 and 13. Then you have got 9, 11, 9, 11 and 12, right? You have got 9, 11, 13, 9, 11 and 13, 42, 80, it is 14, 14, 17 and 21. You have got 6, 9 and 12. This is 8, this is 8, 13 and 17, and this 14, 18, 14, 18 and 14, 18 and 22, this 21, 25 and 30, right? This is 30. So you have got all these activities. You need to find out variance along critical path. And what is variance? It's just square of standard deviation. So first of all, you need to find out TE values, right? And what are those TE values? Calculate TE values first of all for this particular network, and let me draw this table over here. So 10 to 20, 10 to 50, 10 to 30, then so this is your preceding event and this is your successor event, right? Then you got 20 to 40, 20 to 50, yeah, there is one more activity here, 20 to 50 and its duration is 589, 589, right? So 20 to 40, 20 to 50, right? Then you have got 30 to 60. It's very simple how to draw this preceding activity and succeeding activity. Just take first point, right? First node. So what are the outcoming arrows? 20, 50 and 30. So just write 20, 50, 30. The next node is after 10, it is 20, right? So what are the outgoing activities from 20? You got 40 and 50. So just write 40 and 50. The next is 30. What are the outgoing activities? Just one, right? 60. The next one is 40, right? What are the outgoing activities? 80, right? Then next one is 50. What are the outgoing activities? 70, right? Then 60, 60 to 70, and finally 70 to 80, right? Isn't it? It's very simple. Then you need to write down expected values, and for this you need to do calculation, right? So let me write T values for all these events. So for 10 to 20 it is 11.64, 11.66. For 10, 15, 10 to 50 it is 10.17, 10 to 30 it is 10.83, right? For 1040 it is 11. Just check whether this is correct or not, right? So because this is a simple value, let us check for this. So 20 to 40, 9 plus 13, 22, 22 plus 44, 66 divided by 6 is 11, right? Isn't it? So the value for 20 to 50 is, it's 7.67. Similarly for 30 to 60 it is 18. Yeah, we will check this also. 30 to 60, it's 14 plus 22, it's 36, plus 72, 8 divided by 6. So this would be 18, right? For 40 to 80, 40 to 80, this value is 17.17, and for 50 to 70 it is 2.25, it's 2.25, and for 60 to 70 it is 12.83, 70 to 80 it is 9, right. Now you have calculated all these values. Now what? Either you can do in fact you can again come up with different paths over here, right. So you can have path A, path B, path C and path 4, right, and just do the summation of all T values, right, and take only those T's which are there on critical path and find out variance along that critical path. Or you can do one more thing, you can go for T and TLs along all these nodes and find out which path is critical path, right. So as far as this particular question is concerned, the critical path is there, and let us see what is critical path. It is 10 to 20, it's 10 to 20, then it's 20 to 50, it's 20 to 50, right, and then 50 to 70, and finally 70 to 80, right. So this path is critical path. So you can do two things at this stage, either calculate summation of T's for all 4-5 paths for this question, and then take standard deviation and then variance, right. Since we know this is the critical path 10, 20, 50, 70 and 80, we also know the 3 time estimates for all these activities, right. So for 10 to 20, 10 to 20, right, these are different time estimates, 5, 12 and 17, right. So what is standard deviation? It's 17 minus 5 divided by 6, directly calculate variance, right, plus you have got 20 to 50, right, 20 to 50 this. So let me draw a critical path first, 20 to 50, 50 to 70, 70 to 80, right. So this plus 20 to 50, right. So this is 9 minus 5 divided by 6 plus 50 to 70, right. So 30 minus 21 divided by 6 whole square plus 12 minus 6 divided by 6 whole square, right. So this is how you will get variance along critical path. Okay. So you just add all these values, you will get variance along critical path. So this is another example in which what we have done, we have calculated critical path and variance along critical path. So with this, let me complete this session. Thank you very much.